term. And this is called geometric progression. So this lesson will look a lot like the last lesson, except this time now we're going to have a look at finding formulas for when we multiply rather than when we add. So in some ways it's very similar, but in other ways it's actually different, because multiplying, the sequence has a chance to be convergent, where we're adding, the sequence can only ever really be divergent, because if you keep adding a number, it'll just get bigger and bigger.
Yeah.
But in fact there is a way to multiply so that it doesn't keep getting bigger and bigger, that it actually could be getting smaller and smaller. Yeah, for example, like 0.5. If you multiply by 0.5, does it diverge? No, it's convergent. It's getting smaller each time. And that actually will be an important fact for the next lesson. Geometric progression. Okay, so an example would be 2, 4, 8, 16, 32. So each time I'm multiplying by 2. Yeah. So the idea here is you have a term, we call it A, the first term, just like last time, and then you multiply each time by OR.
I have a small question.
Yeah.
Does it have to be always 2, or just the first number and the
Yeah, in this example here was 2. It doesn't have to be 2. It could be, and in fact, just by coincidence, the first number was 2. It could have been something like this: 3 times 2 is 6 times 2 is 12. So in this example, I start at 3 and I'm multiplying by 2 in this case. Yeah. So that's the first term. Does anyone know what the OR is called? If you've studied this before. What was it called last time? Common difference. So this one... Yeah, that's it. Common ratio, yeah. Yeah. Can you see that okay, guys? I'll scroll down a bit now. Okay, so if you look at this, you can figure out a formula here. Our first formula for this lesson is UN equals A or... No, not N or N squared. N minus 1, yeah, because this is the first, this is the second, this is the third, this is the fourth. So you can see the differences of a 1. This is the fourth, and we have a power 3. This is the third, and we have a power 2. So this is our first formula, and now, just like yesterday, we'll look at some examples using this formula. So if you can write this down, please. Okay. Yep, got that? Yes, you have that? Yeah? Okay. So first question is first example, find A and OR in 2, 6, 18, etc. Yep. Alright, so I think we can see what's the first term here? 2. And we are multiplying by, in this case, 3. Yeah. Okay, let's make it a little bit harder now. Find the nth term in 9, 27, 81. Yeah. Okay. So A here is 9 and the OR is 3. So UN for the nth term is A or n minus 1. Now I can actually clean this up a little bit if I wanted to. So I could change this into 9 3n over 3. Add 3 into 9, 3 times. And I know we haven't done these rules yet, but and you don't even have to do this in the exam. In fact, in the exam you could stop here. But what would be the next and final step here if this is like a 1? So you could test that out. For the first term, n is 1. If I have 1 here, it's 3 power 2. What's 3 power 2? It's 9. For the next one, the second term, I put in 2. 3 power 3 is 27. So it does work here. This is the answer, although for exam purposes, they don't usually care if you simplify. So you could also just give this as the answer. Both are fine. Yeah?
Sorry.
Yeah. How far? Here?
Yeah. Can I help?
Okay, yeah.
I think that's how.
Yeah, unfortunately, we haven't actually done these rules yet, so I'm not worried if you didn't know that because I didn't teach you it yet. It's just some people might have known it from previously seeing it. So I'm perfectly happy if you stop here. There are rules of powers, rules of indices that I think will be in maybe the next chapter that we will actually do. So I wouldn't stress about this. If you can get to here, that's enough. And this we'll actually look at in more detail later. It's just for the people who have seen it, I just wrote it down. Okay. Can I go on to the next example now here? Yep. So the next one is how many terms are in, let's see, we'll say this sequence. 2, 4, 8, dot, 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 dot. Now, this is a lot like what we did last time. It's the same idea. Do you remember the key step here? What do we do first?
Find A.
Well, okay, first find A. A is 2 and OR is 2. And then next, yeah, UN equals 128. So that means A or n minus 1 equals 128. That means 2 n minus 1 equals 64. If I divide by 2, yes? 2, 4, 8, 16, 32, 64. 2 power 6 is 64. Yeah, so n must be 7. Can you see now?
How did you find the
brain power. Yeah, if you want to know a way to find it, I'll show you on the side here. Can I go to the side for a moment? Yeah. So for example, I'll take a different number, like 512, something like that. So actually you can do what guys, come on. You can do what I did, I think maybe 2 weeks ago, using the tree. So for example, you think of two numbers that multiply to make 512, and it can be any two numbers. So for example, one possibility is 256 multiplied 2. And the 256, that could be, I don't know, 128 by 2. and this could be 64 by 2. And you go, oh, 64, that's 8 by 8. What about the 8? 2 by 4. And 4 here? 2 by 2. How many 2s? Yeah. 1, 2, 3, 4, 5, 6, 7. Oh, yes. 8, 9. Okay. So it's 2 power 9 then. Yeah. Now there is another way to do this. Not doing it this way. A quicker way using something called logs, which we haven't done yet, and we will. So basically, you can use the factor tree, and if you need to review that, we did it in the lesson on surds. Okay, the next example. I tell you that I want you to find A and or if the fifth term is minus 16 and the 10th term is 512. So, again, just like yesterday, you only need to be told 2 terms to find A and or here. So in this case, I told you the 5th term and I told you the 10th term. So if we look at the 10th term first, we can say A or power, what power for the 10th term? 9 equals 512, and then A or power 4 must equal minus 16. Now the real question now is, how can I put these together so I can find A and or? Divide how?
A are 9 divide A are
Yeah.
R power 5.
Yeah. What you can do is, not only can you add or subtract equations, but you can also multiply and divide them. So you're actually allowed to divide these pairs. So you have A or 9 over A or 4 equals 512 over minus 16. So or 5, this is 2 9, 2 4, 2 5, 2 4, 16, 32, isn't it? 32. So then or is the 5th, thank you, minus 32. Or is the 5th root of minus 32, which is 2 or minus 2? Minus 2. Minus 2. Okay, and then how can I get the A? What would be the easiest way to get the A? That's a 10, believe it or not. Yeah. Substitute it in here. So now you get over here, alright, it's A minus 2 power 4 equals minus 16, isn't it? 2, 4, 8, A 16 equals minus 16, so A equals minus 1. That's the answer there. Okay. Got that? Not yet. Continue? Okay. Next, we have to do the formula for the sum. So suppose I want to calculate the sum from the first n term. So we have a plus a or plus a or squared plus etc 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 all the way up to a or n minus 1. Now, does anyone know the trick here to simplify this formula? Partial credit. You remembered yesterday's lesson. Congratulations. But it does not work this time. Times or. Correct. So I'll multiply by or, and I get a or plus a or squared plus a or cubed, etc. plus a or n. Good. Next. Minus. Sn minus or Sn equals. So when you minus, you notice that this one cancels with this. This one cancels with this. The next one cancels with this, etc. Until that one cancels with the one before it. So you're left with this term on the bottom and this one on the top. So it means you're left with a minus a or n. So you have Sn 1 minus or equals a 1 minus or n. When you factor S and a on the left and on the right. So you're left with Sn equals a 1 minus or n over 1 minus or. And of course we must say or is not equal to 1 here. Got that? We'll have a look at some examples now. So, the first example here, calculate, let's say, S9, the sum of these 9 numbers. 1 plus 2 plus 4 until 256. Okay, so what's the A here? 1, the OR 2, and the N 9. Okay, S9 will be A 1 minus OR power N over 1 minus OR. 2, 4, 8, 6, 7, 8, 2. Now don't tell me, I can do this. 2, 4, 8, 16, 32, 6, 4, 128, 256, 5, 12, 5, 11? No. How could it be minus? They're all positive. And the bottom is minus. Thanks. Is it 511? It is, okay. Jerry is trying to be helpful. Thank you, Jerry. Okay. So that's our first example of using the formula. Let's have a look at another example. Can I scroll down? Mm-hmm. Yep. So this time I don't tell you the n. I say find the Sn here, and we will be adding, let's say, 2 plus 6 plus 18 etc. Okay, so here the A is 2, the OR is 3, and the N is N. So we have here Sn equals A 1 minus OR N over 1 minus OR. So that will be 2 1 minus 3N over minus 2, which will be minus 1 minus 3N, which will just be 3N minus 1. That's the answer there for that one. Got this? Yeah. Yep, okay, let's have a look at the next one. Okay, so the next one now, and we'll do one like this. Okay, so what's the A here? 1. Now be careful, what's the OR? Minus 2. And the N? We need to find it. So, the trick is we say 256 equals UN, which is equal to A or N minus 1. So 256 equals minus 2 power N minus 1. 2, 4, 8, 16, 32, 64, 120. This is 27, isn't it? Is it 9?
No.
Is it 7? 2, 4, 8, 16, 32, 64, 128, 256. Yeah. It's 8. Sorry, 8. Equals minus 2 power N minus 1. But just to make it a bit clearer, 2 power 8 is the same as minus 2 power 8, because remember I said last week, if it's an even power, doesn't matter about the minus. So minus 2 power 8 equals minus 2 power N minus 1. So we can see N must be a 9. So now I can use my formula. S9 equals A 1 minus OR power N over 1 minus OR. Let me see, that will be 5. I can do this. 512 over 3. I can do this. Let me do this. Let me have this moment, please. Right. 512 over 3. So that's 1, 2. It isn't 512. It's 2 power 9, not 512.
You can do it.
Thank you. He believes in me. 511 over 3. So what's that? 1 and 2 and 8.
No, 513.
That's true. 513 over 3.
Come on.
Hold on. Give me a moment. That's 1. 7, 1. No, it's not worth applauding. It's not. That took too long to do. 171 is the answer here. Okay, let's have a look at some more examples now. Can I scroll down? Yes? Okay. Right. Now time for a hard one. I think I'll do two of these because, no, I'll do, I'll do this one. So I tell you, find A and or if the sixth term, guys down the back, I can't teach when you're talking, please. 486, and the sum of the first two terms is 4. Let's have a look at this one now. Okay. Got this? Let's have a look. So if the sixth term is 486, then I say A or 5 equals 486. And the sum of the first two terms is 4. Now you could use the formula, but because there's only two terms, it's not really necessary. I can just say A plus A or equals 4. Although if you want to use the formula, that's fine. But I mean, it's only two terms, so no big deal. So we get A 1 plus or equals 4. Yeah. Now, substitute or divide, both work. Yeah. So here you could say, for example, A equals 4 over 1 plus or, and then you can put that back in here. So now you get 4 or power 5 over 1 plus or equals 486. I'll just give you a minute to try and solve this. I want to see if you can come up with any ideas. So I want you to continue for me from here. Find or. Okay, anybody come up with any ideas on how to solve this? Go ahead. Helps some, but not much. Divide by 4 perhaps first. So or power 5 over 1 plus or equals 1, 2. I don't really want it like that. I want to try and keep it as a fraction if I can. Anyways, let's have a look at how to solve this. So that would be 243 over 2. Now, what should we do next? Well, some of you might be thinking I should do this. But it doesn't work. Well, I mean, it doesn't help. Here's the trick. Watch carefully. I can change this. You've spotted it. Change this into or over 1 plus or. 5. And this is equal to, let me think carefully here. (243) is a 3 power, isn't it? It's 3 power 4?
Yeah, 3 power.
3 power 4 over 2. Okay. Sorry, I keep dropping my 5 here. Oh, 3 power 5, thank you. Now, if somebody is sitting here looking at this, you might be starting to realise, oh, the left and the right, they're starting to look similar, yeah. But we're not quite ready yet. There's still a bit more work to do. Not quite there yet. So the problem really is, although we've made progress matching up the top, we've not really made much progress matching up the bottom here. Yes, which is a problem. So, what I'll do next is I'll do this. What's minus 3 power 5? Minus 243. If I divide by minus 2, this is still the same. There's no change. Still the same. So now I have or power 5 over 1 plus or equals minus 3 power 5. And I could change minus 2 into 1 plus minus 3. Now look exactly at what you have. Now you see, he sees it. Once you see it, you can't unsee it. Right, so we have here or power 5 over 1 plus or equals minus 3 power 5 over 1 plus minus 3. So obviously or has to be minus 3. And then this can give us the A. Putting this all the way back in here, I get A equals 4, listen, 4 over 1 minus 3, 4 over minus 2, isn't it? Minus 2? Difficult. Write this down carefully. Yeah. How did I get I needed to think of a way to write minus 2 in a form of 1 plus a number, because what I'm trying to do is match the left and the right perfectly. So I realized 1 minus 3 is minus 2. It's a matching exercise. You're trying to manipulate it so you have a perfect match on the left and on the right, which has happened here. Okay.
Yeah.
Did you write that down? Yeah. Yes, people still write. Anyone need more time, or I can scroll down to the next example then? Yes? Say again? Positive 3 and positive 2. Which step am I looking at here?
No, see, I have a positive 3 and positive 2. So negative, you get 486.
Oh, you're saying if these were both positive?
Yeah. Would you get the same answer?
You would get Well, no, on the bottom you would have 1 plus 3, which would be a 4.
Put it back to how you found 8.
Yeah.
That is 8 or power 5. Yeah. So if you go at positive.
Guys, hang on. Listen, I can't hear his question when people are talking. No, sit down. Your classmates are being quite rude and disrespectful to you. He's trying to ask me a question. Okay, so which step am I looking back on?
How you found 8, right?
Yeah, here.
Yeah. Okay, so if you had a positive 3 and positive 2, you put it in.
Oh, you're saying if 3, 2 is a possible answer as well, is what you're saying. I get it, yeah. Because if you used 3, then you'll get a 2 here. So we just need to check actually if positive answer makes sense. And that's fine, because what I was going to say here is there's possibly other answers as well. So we better check the 3. I feel like though if I put 3 back in here, it might be false.
I put it back into
Which step after this one?
No, I put it back into A or Y.
Oh yeah, I get that, and that gives you the A.
Yeah.
But we need to check firstly that 3 is an actual valid answer. So if I put it here, I can see if it is or not. So if I just go to the side here, 3 power 5 over 1 plus 3. That will be what? What do you get here? 243 over 4. And we were looking to get 486. So in this case, the positive answer is not. Now it could have been, but I usually find that happens when the powers are even. Because what happens is when they're even, the sign doesn't matter. So if this was a question that had a 6 in it instead, then we'd want to check the positive answer as well. Yeah. By the way, can your graphing calculator, like if you hit this in on the graphing calculator, it could solve it. And does it give 1 or 2 answers? Yeah. So it's a good way to check if you want to check it this way. Okay. Can I scroll down to the next example then? Yes. Guys, my attention has been drawn to you talking 3 times now, so please don't make it a 4th time, okay? Thank you. Okay, so next example now. So we have this sequence is in geometric progression. So this is a lot like what we did last time when it was in arithmetic progression. What is the key idea here that we're going to make use of? Yeah, or equals. So if I look at these two, what can I say or equals? So how would you get the or?
Minus 4x minus 4.
Over.
Minus 4x.
Yeah. But if you look at these two, same idea. But if this is an or and this is an or, then this should be the same as this then. Yeah. Over that should be the same as this. Okay, now what to do next? Yeah, what's this called? The thing. Ah, the thing. Sure, why didn't you say that? What's this verb here? Cross multiply. Cross multiply. So minus 4x minus 4 squared, yeah, equals minus 8x minus 4 multiply minus 2x plus 3. So multiplying we get 16x squared plus 32x plus 16 equals 16x squared. Let me see, that's an 8x, that's a minus 24x, isn't it? So minus 16x minus 12. They cancel. I get 48x equals minus 48. No, what? Sorry, I was doing so well. 48x equals minus 28. That's okay. So we get x equals minus 28 over 48, which is minus 14 over 24. Minus 7 over 12 is the x then. Okay. Harder than last time. Can you see?
Yeah.
I'll zoom out a bit. Okay. Got that? Yes, you wrote this down? Okay. So I'll give you some questions to try now. Let's see. One, two, three, 4, 5, 6, 7, 8, 9, 10.
Oh, no.
Hi.
A, B, A, B, A, B.
Number 10 only has one. Also.
What?
No.
All A. Too kind. Try these for a few minutes.
Number 10, that E doesn't mean exponential, right?
Oh, it does actually, which, no, we'll forget about 10. So just,
I want to do that.
are you welcome to try it.